Istio, and this is going to be a very high-level talk. It's more about what we think is behind Istio and not going too deep into a lot of the technical details. Istio.io is where you can find all of that. There's a lot of documentation. The community is doing a really good job of educating us all about this. So good news, as we all know, cloud computing won. I've been in this business now since the early days when S3 was first launched, and then I was at Sun, and we did Sun Cloud for a while. Now I'm at Cisco. And about 25, 30 years ago, I was actually doing distributed computing, massively parallel supercomputing. And so I keep seeing the same things come over and over and over again. And what is interesting that no single company won cloud computing. They're dominant players for sure, but what we're seeing, particularly enterprises and everybody else, they're using multiple clouds. Why? Because they don't want to be locked in. They want vendor choice. And also, I think as we go forward, we're going to see the different major cloud providers sort of specialize in different aspects of this, whether it be the kind of advanced AI services that they're using, or storage, or low-cost computing. And we look at across the world, then we look at China and India. National sovereignty, data protection, those are going to be major issues. So it's definitely a world of multiple clouds. And that makes it rather interesting, because all of a sudden now, whether you are in an enterprise or you're in a branch office or you're at a service provider or you've got multiple POPs out there in the world, you've got all this cloud infrastructure up there from different providers that unfortunately have different APIs. Years ago, there was an effort to try to standardize on the cloud API. Of course, none of the major cloud providers wanted that, because that would lose a lot of their ability to differentiate and compete. And so we've got multiple APIs, but we have pretty much the same model. So we have a very kind of consistent model, how we operate in these public clouds. So that's in our advantage, and good sign. What makes it hard now is that there's lots of choices. I mean, this is trying to show everything from sort of a customer premise where companies like Comcast and other service providers are trying to run services out on premise, deploy them out there and upgrade them, because to go out into a customer site and replace a piece of equipment is really expensive, and they lost all the profit from that customer for years. Instead, they want to be able to deploy it like you would in a cloud. It's a virtual system, so just deploy the new application out there. And then all the way we know where the data center is, and the data center is getting bigger and bigger and bigger, but further and further and further away from the edge. So things that are very latency sensitive, autonomous vehicles, those things where you really have to have very choice things. We have to find a way to put applications there. So this is, a very different world, and we have OpenStack, we've had KVM virtualization, we've got VMware, we've got Docker containers. And there's a lot of things that you have to consider now. So when you are starting up or working in a new place or whatever, and having to decide which of these technologies do you use, it's getting to be very, very complex. So we think that we're always trying, as computer scientists, go to another layer, build another layer on top of it, and simplify everything. The world always then works against us and goes, oh yeah, well now you just made it so I have more and more places to run things. So this world of multi-cloud is really upon us now, and it takes some real consideration. So Kubernetes is great, and containers are great. Actually, I remember when there were Solaris zones and containers actually back on mainframes. But that makes it much easier to sort of have fast startup, because you've got a much more lightweight process than a virtual machine. You're giving up an awful lot when you're not on a virtual machine. It's not your own computer anymore. You actually are just like in a namespace. But you have the possibility, back to the early Java days, where it's part of the Sun, the early movement there, that you wanted the consistency. You want to be able to run the same application in many of these different places. Pretty much unchanged. So run anywhere is back again. We'll see if we can make it work this time. And there are real challenges. I mean, containerization really does pose some real issues for us in a multi-cloud world. One is that there's lots of choice. Again, we've got lots of providers of containers and different orchestration systems. Kubernetes solves one part of this problem. And that earlier there's a talk about what do you do on bare metal? Well, do you have some way of orchestrating the infrastructure underneath you? Well, that's where other things such as OpenStack might come into play. We've got hybrid environments where you want to have virtual machines talking to containers, talking back into an Oracle legacy database. All of these things become sort of challenges that we have to start to try to overcome. So one of the things that we've done at Cisco, for example, is that we are bringing out, like many other vendors, a Kubernetes platform running on Cisco's data center infrastructure, UCS systems. There's native Kubernetes upstream, and it's a way for our customers to be able to have a consistent container environment, just like they would at Google or at Amazon or any place else. That consistency is really important. So we're working with other of the large cloud providers, recognizing that multi-cloud is the state of the world today. All the information is not going to go to the public cloud, nor is it going to stay in the data centers. So there's going to be in both places. Workloads really need to be able to run in both. And so we are partnering with Google and others to make that really happen. What you really want to do is have now this kind of consistent environment across those things. So if you are developing a Kubernetes application, you should be able to run that just about wherever you can, wherever Kubernetes is running, whether it be in a public cloud or in a private data center or in a hosted private cloud. You should be able to move those things there. That same promise was made by Java. And we all know that actually the individual computational load isn't the hard part. It's the system around it. And that's what you really need to start thinking about to make this really work. So let's go through the sort of history. Well, back in the old day, there were monolithic applications. We broke those up into different kind of components, and we then built that into one big application or whatever, and then we deployed that. And if we wanted HA, we had a hot standby for that or something else. And the world was sort of good and simple. Not very exciting and not very, scalable. It was not scalable at all. You had to buy bigger and bigger machines, scale it up through vertical scaling and hardware. So we moved to, okay, well then there's a hybrid world. This replaced kind of client-server computing. You want to use some resource that's in a cloud, like S3 for storage or whatever, and run something on-premise. Be able to use those things. And then we come along and we go, that's not the best application design model, though. What you want to get to really is microservices. And the reason why microservices is all the rage now is that it simply says that let's break up the application into primary services that individual application developer teams can develop and deploy. Do something really simple and do it well. Don't make the application developer do everything that's involved in an application. Have them do one part of it. Perhaps the content management or the security system around it or the identity system or the client database. Have that application team serve that service and do it really well. The issue is now you've introduced all these dotted lines. That's the communication between these things that you now have to pay attention to. And guess what? We've now entered the wonderful world of distributed systems, as was mentioned in the earlier panel. And for many of you who have had CS degrees or whatever, this is one of the graduate level courses. You learn about all the horrors that can happen when you have network partitioning and you've got intermittent failures, or when you don't know whether something's really failed or not. Action at a distance until we get to true entanglement and things like that. We've got a lot of issues here, even in simple things about how do you keep track of time. And you want to be able to have observability. You have to be able to know what's going on. You can't just run dtrace or poke inside with ADB or whatever inside of a single execution because something's happening over there. So you have to be able to look at everything that's going across the system. You have to do traffic management. What happens if one part of that system misbehaves and that starts sending out a lot of packets or making a lot of demands on other things? Whose fault is that? And how can you also now start to redirect some of the traffic? Because now we live in a world of continuous deployment, or so we'd like to think. And you want to be able to have rolling upgrades or canary deployments. So you want to be able to shift traffic around until you can get the system back to a known stable state. And of course, you want security and policy. How can you trust this other service over there? Is that still your service that you're talking to? Or did somehow a rogue system get in there, a rogue component that you're now talking to that's actually exploiting, getting rid of all of your data, stealing all of your data? So, services should be really simple. And that way, you really can make it advantageous for individual development teams to focus on the service. But they quickly get complicated. And just show you a simple example. So those of you who are, been building like, web-based services for a while know, you have to do all these things. You have to be able to have load balancing in front of that. You want to be able to have security and policy. You want to be able to encrypt the traffic coming out of here. You want to be able to do different request routing and everything else. And then you have to have logs and metrics and ways of analyzing all of that. So for a web team, they're used to doing all of that. But what about that content server team? Or about the order management team? Or the payments team? Instead, now that you've got this distributed system, each one of those teams has to know how to do all those things. So what was simple now has become very, very complex again. Because now you also have to say, they should be doing these things all in the same way. Where we collect our logs, we should be collecting them in the same place. We should be aggregating them. If we want observability, we want to know what's going on between these services. So all of a sudden, what was a very, very simple way to think about it, microservices, has become complicated because what we've entered is this wonderful world of distributed systems. Well, there is something we can do about it. And this is where Istio comes into play. What if you really say, let's make all of those services simple again, offload all the responsibility for the communication aspects, the observing of the traffic management, the identity management, security, offload that to the service mesh, essentially another service. And now each one of these components gets simple again. And now you have a single place also where you can answer a lot of these questions. Who's talking to whom? Where are we going to aggregate the logs? Or do we have a consistent identities policy? Are we how are we doing key management, rotation? All of those things can be handled through the service mesh instead. So this is the basic picture. If those of you who are looking at Istio on the web, wherever you see this over and over and over again, it's important to sort of keep this in your mind. It's doing what is usually done in this kind of a case in communications, that you separate out the data plane, where traffic is actually going, from the control over where the traffic goes, into a control plane. So Istio is made up of this primary architecture, having a control plane, which one controls the configuration, and then a data plane, which is in front of each pod here, which is the components. What we put in front of these things is a proxy. That is right now, Envoy is one of the choices. There's several choices then for what kind of a proxy. All traffic from this pod has to go through this proxy. That means that's a point of control. It's a point of observability. It's a point so that you can actually now encrypt all of your traffic. You want to be able, that makes, again, that application developer's job for that component, which is deployed as a pod, very, very simple again. And all of the work now is done through these other components here. Mixer is a way that you can actually now control where the traffic is going. Pilot sort of sets up the configuration and the basic traffic management, but also now you can take telemetry back up, and you can pipe that out to some other service. You can also offload a lot of the authentication and security and key management out into another authentication system. So all of this now, again, makes it easier to develop these pods where they don't have to worry about that. What do they care about? They're talking to local host. That's the only place they can talk. That local host is picked up as this Envoy sidecar proxy and now manages all the communication. And that's what is the real power of Istio. So there's lots of different options, and Envoy is sort of the default for a lot of these. It came out of, what are we doing here? It came out of Lyft, so it's really been battle hardened, and it's been, it's really, I think, a very excellent kind of HTTP proxy on this. And it really can provide all of these kinds of capabilities. So more and more, as Istio is being developed, we're leveraging so much of the capabilities that are coming out of these proxies and then controlling them through the control plane. So here's just a very simple example. A canary, deployment, canary testing. You've got a new service. You've got a new version of your service. I've got two services that are talking to each other here, Service A and Service B. We want to roll out now a new version of Service B, but we don't want to have to tell Service A anything about it. We want it to just affect Service B. So essentially what you can do, because you can have control over the traffic from Istio, you can deploy now version 2 of this service. Now, most of the traffic's still going there. Once you've deployed this, now what you want to do is a canary test of this. So you want to be able to have Istio now divert 5% of the traffic over here. This is essentially a one-line change in the route rules for Istio. To just take 5% of the traffic, keep load balancing the other 95% across these. Observe what's going on here until you can really feel confident that this is what you really want, and then flip it so that now all the traffic goes to service B. And with that, you essentially have accomplished something that remember, the individual developers had no idea that was going on. They were just developing their service, and they were deploying that pod. It's the operations team for this system that makes that change happen. Now, one of the places that so Cisco is heavily involved with Istio right now, and people on my team are contributing. What we're looking at okay, Istio is really designed for a single Kubernetes cluster today. We are looking to make that expand so we can go across multiple Kubernetes clusters and make it so that those clusters themselves may be on different clouds. Now, there's several ways to do this, and the most simple way is to have a single control plane across multiple Kubernetes clusters, and they can be in multiple data centers or clouds. The other way to do that is through a federation model, where you actually are federating multiple Istio control planes and service meshes. And that one's the community is developing as well. So we'll see which one sort of ends up being used, and it might be that one is actually preferred, or in one use case better than another. With this model, that what we're really trying to say is that you can even have things such as out on the edge, where you don't want a full-blown service mesh out there. You just want to be able to have a proxy that you can talk to. Anywhere you put a proxy, you can include into the service mesh. And therefore, you can start accomplishing some of the things you want in this kind of multi-cloud world that we're talking about. So my view is that this service mesh is really radically different. It really is affecting the way that we're thinking about applications, because it really does abstract away the details of this kind of service-to-service communication, which I think is sort of the hardest part of dealing with distributed systems. And with this, though, you can have a consistent policy. You can have load balancing, encryption, authentication, all of this across all of your services without each component having to know about that. And it's really the easiest way to connect these things and make these changes without changing the service code, because the service code is really delicate, and you really don't want to have changes that have to be reflected across every component. Instead, make those changes in the service mesh itself, what Istio is doing. This makes it much, much easier for IT ops, or whatever we want to call it today, in getting the observability around that and everything else. And so one way to think about it, what Kubernetes has done in terms of orchestrating containers and these pods and bringing the managing on the compute side, Istio is orchestrating communication. And it's a communication between these kinds of services. So the biggest change, I think, and impact on this is that we are changing the way we think about application and service development. Because long term, I think we really are consistently been trying to move where applications really become assembly. Those of you who ever did any hardware design or anything else know the tremendous advances we've received when we have catalogs of semiconductor components we could lay down on a board and build a system out of it. And that's where we need to move with software. And now we've elevated that into the cloud, so we really have to talk about how do we assemble all of these services. You're never going to have within your own organization the advanced AI machine learning capabilities. You're going to want to use an AI machine learning service out there. You're going to require the assembly of these different services in order for you to deliver an application. And something like Istio, I think, will allow us to make that change. So I think that's it. So I think I'm on time. And thank you very much.
Okay.
Istio is it replacing SDN controller? It's kind of simple SDN controller. What is it?
SDN, I think SDN controller is at a much, much lower level. So the question really, how is this different than an SDN controller? It has a lot of common attributes in that it generally is a separation of a control plane from a data plane. But this sits on top of all of that mess, so that the primary networking fabric underneath it may be driven by SDN. This is for an application developer and for the IT operations of an application. So it's at a much, much higher level in like many ways. We see these patterns repeat at different layers, but this is way up at the application. This is application level networking.
Question here.
Other questions? Yeah.
Oh,
Raise your hand where you, yeah,
Yeah.
great.
okay, this might sound stupid, but what if the mesh, it's a service mesh itself, fails? All other services going to be, all microservices going to be failed?
Okay, I think you're asking, so what is actually the mesh part of this? And it's probably because we didn't show enough of the services connected. When you connect up like multiple of these components, multiple pods that are now being connected up, front-ended by these proxies, that becomes a mesh. And a mesh is simply saying it's a integrated, self-contained network of communication between those services.
Right, if that mesh itself fails.
If the mesh itself, so what's nice about it is that this is sort of very resilient because each of the proxies can talk to all of the other proxies. So you already are in a distributed system. And the mesh, nodes in the mesh can go down, the rest of the mesh can stay running. Now, the control plane, though, is another element of this, right? So what happens, the proper question might be there, what happens if the control plane goes down? Well, you can actually run, and there's other work that is being done to make the control plane itself resilient in the same way. So you can run multiple of those services. They just need to be able to coordinate so that they're consistent in their application, the configuration and everything.
Thank you.
And for example, these things are run on top of Kubernetes. So Istio runs on top of Kubernetes and uses all of Kubernetes services to keep the control plane and everything else running. Great question.
So what is the scalability of the control plane?
Unknown at this point. Yes. So what is the scalability of this today? And my answer was it's unknown. It's designed to be scaling to tens of thousands of components. I don't know that anybody's run anything that large yet today, but I think that's one of the things in the community there that we're trying to work on is do scale performance testing as this as well. Istio is at right now 0.812, I think it is, if anybody's in the community here. And so towards the end of July, August is when we're expecting like the first 1.0 version to be out. Other questions? Yes?
How much of a performance impact is there? The packets being bounced around quite a bit, or is there...
Great question. Yes, so there's lots of different aspects of performance. One is what is the overhead of having the sidecar proxy for all the communication? That's the obvious one. I ask my guys that all the time. It's not viewed to be very large. I mean, I think 10% may be a performance hit, but again, it depends upon what kind of traffic. If it's a lot of very small packets, it might be larger. The other way to characterize that is what is the performance of itself? And I know that right now we're looking at it from the point of view of how chatty is the communication back between the proxy and pilot and things like that in the control plane, because that seems to be pretty chatty now. Yes. Do you have an answer on performance?
No. No, but it seems like repeatedly over and over again we solve a solution, we come up with a solution for the web application side of things, and then we find out, oh, but wait, the data is different. And we've seen that in containers. And I'm just kind of curious, do you think we're going to see the same thing here with something like Istio, where, okay, the web traffic going through a sidecar, that's fine, but why are we doing that with data? Why isn't the database calls just going directly to the database?
That could be in the realm of an architectural design, I think. So if one of your components or whatever needs to just talk directly to a database, so be it. You wouldn't connect just the front end. I don't think you'd put a proxy right in front of your database. I think that might not be the best design. But again, I think, and then the other question I think related to that might be, okay, what if you've got a streaming service? That's other places. And so one of the things, for example, we're looking at Cisco is that we've got another open source project called FDIO, which is VPP, which is a user space, very, very fast software-based router. and that we're looking to embed that essentially inside of the proxy, so that you can have very high performance, line rate, streaming services coming out of that, and also full-blown routing and everything else that you'd like to do. So I think like everything else, let's get the model right and the abstraction, see if the primary goal is to make it easier for application developers. Then if there's performance issues, let's attack those and we'll know what ones we got to go after.
So do you have any plans to implement layer 7 router? Because application talks to another application using some API, maybe gRPC based. So in many cases, you can avoid packetization and going for TCP connections if, say, you know that both entities are collocated on the same host, so you may be able to connect. Similar to what FDIO does with TCP connections, you can probably level this. Do you have any plans to do that?
We'll keep in mind, this is at layer 7. So this is the routing rules and everything else like that can take advantage of everything they can see at layer 7. So they do a lot of that from the proxy to proxy. So the proxies themselves are doing this routing. They're sort of doing load balancing themselves, and they also are doing selection. For example, you can have a rule in there which says that anything that looks like if some of certain browser will go to this, service over here. A mobile app will go to that service. And that's, you can configure it at that level.
What I mean is, say, gRPC, it's use TCP underneath. And if you can replace a gRPC implementation at some level, so that it will talk directly to Istio without going through the network stack, then you can do shortcuts.
So let me suggest that I've got Shannon McFarland here. He might be able to address that really at the detailed networking level right after the break. I think that's an interesting conversation, what's possible there. How we doing? One more question and then we'll break. Yes.
Yeah, could you go over some of the things that are communicated between Istio and Kubernetes? Like, can Kubernetes tell Istio to do something? Is that possible?
Istio is really sitting on top of Kubernetes. So
Yeah,
Istio
but there's a communication link between them.
Is using Kubernetes to maintain its own control services and to actually deploy and keep the pods running. Is that address
Well,
what?
Can you go in more elaboration about how that is working?
So Istio, to my knowledge, people aren't thinking about Istio orchestrating spinning up containers. That's really the job of Kubernetes. It takes advantage of all of the capabilities in Kubernetes to instantiate itself, but it's really talking about communication then between these different services, each one of which is managed by Kubernetes. If that makes sense.
Does Kubernetes tell Istio to do something?
No. Because again, this is much more of a layered architecture. So on top of Kubernetes is Istio, at least today.